Hello friends, welcome to this class. Today we are going to look at ratios, proportions and variations. So let's get into the basics. What are ratios? Ratios are a measure of how much of one thing is there compared to the other thing. So when we are talking about, let's say I have twice the amount of money you have. So this is my money, this is your money, and I have twice of the amount of money you have. So if you have X, I have 2X. If you have, let's say, $100, I have $200. So there will be a certain ratio that will be maintained whatever these individual values are. So that kind of thing is written as my money to your money is in the ratio 2:1. Right? It is always written as A is to B, and mathematically it is treated as a division relationship. Let's say, for example, I am saying, why do we treat it as division relationship? Let's look at this. So I am saying my money to your money is 2:1, correct? So I write it as 2:1 is equal to my money divided by your money, right? So you will always find that my money, the absolute amount, divided by your money absolute amount, it will always come out to be 2:1. So for here in this example, my money by your money will be 2:1, right? So basically A is to B is indeed a division kind of relationship, and it can be expressed as a fraction. Proportions say that two ratios or fractions are equal. So when I say, when I equate two fractions, let's say one A is to B is one ratio and C is to D another ratio. When I say both are equal, we are saying that they are proportional. It also means that A into D is equal to C into B. So we are doing cross multiplication. A into D is equal to C into B. There is another way to write this proportion. A colon B is equal to C colon D, the way we saw here. Okay, so the main thing here is when things are in proportion, their relative sizes are the same. So let's say what I'm saying is I have a map of a house, and the base of the house is rectangular, 50 feet by 20 feet, right? And map is a smaller picture of the base of the house, and what I have here is 5 centimeter. The base is drawn as 5 centimeter and 2 centimeter. But you will see that this map is actually proportional to the house, right? So why is that? That is because the ratios 5 centimeter by 2 centimeter here and 50 feet, let's say, divided by 20 feet here, both are same, right? So these two ratios are same, so that means these two entities are proportional. So that is what we mean by A divided by B is equal to C divided by D. Variations. So what are variations? Variations are actually movement of one variable with another. Movement of one variable with another. Now let's consider this example. Let's say you're buying a number of chocolates. One chocolate comes for $2. So if you buy 10 chocolates, you're going to have to pay $20. For 15 chocolates, you will have to pay $30. 100 chocolates, $200, and that way, right? So you'll see that these variables, the amount you pay and the number of chocolates you buy, have a certain relationship. Number of chocolates you buy is going to influence the amount, and the amount is going to be dependent on the number of chocolates. So this can be called as a dependent variable, whereas number of chocolates can be called as independent variable. So these kind of relationships we can express with respect to variations. Variations are written with this symbol. So in this example we can say that amount varies with number of chocolates. There are two types of variations: direct proportion and inverse proportion. So when x changes with y in such a way that x divided by y is constant, then x is said to be directly proportional to y. So let's look at this. What we are saying is x and y are related. X changes with y in such a way that x divided by y is always a constant. Let's say that constant is k. So what this means is x is going to be ky, right? So as y is increasing, x is increasing, right? Like for here in this example, equation we'll get is amount is equal to 2 times the number of chocolates, because each chocolate comes for $2, right? So here amount by chocolate is a constant 2. So this kind of relationship where if one variable, the independent variable increases, the dependent variable also increases. This kind of relationship is direct proportion. You will see that because both and you will also see that both of them establish a relationship where their ratio is constant. Another example here is area of circle is directly proportional to square of radius. Area of circle is pi r square, we already know that, and this pi happens to be a constant. So area divided by square of radius is always a constant, so area is directly proportional to the square of radius. The other type of relationship is inversely proportional. When x changes with y in such a way that relationship x into y is constant, x into y is equal to constant, we say that they are inversely proportional. So let's look at this example. Time required to travel a distance is inversely proportional to the speed of travel. What it means is, if I am traveling faster, if my speed increases, my time will come down, right? The ratio we have already seen in the last class, that speed is equal to distance by time. So you will see that to travel the same distance, d is equal to st. So that means speed and time establish a relationship where x into y, speed into time, is a constant distance. So speed increases, time decreases, and this is inverse proportion. So we say that time required to travel a distance is inversely proportional to 1 by, rather inversely proportional to speed of travel, which is written as inversely proportional to 1 divided by the other variable. So one thing you have to remember is, whenever whatever proportion it is, let's say x is directly proportional to y, just change this symbol to equal to and add a constant. So what you do is you do x equal to, add a constant y. This is the relationship you get mathematically. When you say x inversely proportional to y, this is how you write it. Now same thing, you just replace this by equal to sign, add a constant k, and that's it. So you will get that x into y is equal to k. So let's look at practice problems. Please pause the video and see if you can solve this. Total rent of a guest house includes fixed cost and an additional cost per guest, which is the same for every guest. If the total rent is $2,000 when there are 50 guests and $3,200 when there are 100 guests, find the total rent when there are 200 guests. Okay, so we know that equation we get is rent is some fixed component f plus there is a cost related to how many guests we have, and that is directly proportional to the number of guests. For every guest, let's say the cost is x dollars, and we have number of guests into x dollars, right? So if you have one guest, it's going to be x dollars, two guests for 2x dollars, that way. On top of that, we'll have to pay a fixed rent, and this becomes out to be the total rent. So this is the relationship we have among all the variables involved here. And let's look at this fact now. If the total rent is $200, fixed component plus when there are 50 guests. So when there are 50 guests, we get 50x as the variable component. So this is one equation we got. And another fact we know is $3,200 is the rent. $3,200 is the rent. Fixed components plus variable component for 100 guests. Variable component for 100 guests is 100x. So these are two variables you got now. What we'll be able to do is we'll be able to come out with value for fixed component and also value for variable component here. So let's do that. Let's get rid of this f first. We'll subtract this equation from this equation. So what we get is 1200 3200 minus 2000, 1200. F minus F is 0. 100x minus 50x is 50x. Right? So x is equal to 24. If x is equal to 24, let's put x is equal to 24 in either of these equations. Let's say I put it here. So I get 2000 is equal to F plus 50x. 50x is going to be 1200. So that means fixed component is $800. Right? So now we'll be able to do the total, we'll be able to calculate the total rent for any number of guests because we know both x and f. So the question is find the total rent when there are 200 guests. For 200 guests, the total rent is going to be fixed component 800 plus 200 into x, 200 into 24. So that is going to be 800 plus 4800. So that's going to be $5,600. $5,600 is going to be the total rent. Let's move to the second problem. Please pause the video and see if you can solve this. The price of diamond directly varies with square of its weight. So we have two variables. Price directly varies with square of its weight. That means price is equal to some constant into square of its weight. This is a basic fundamental relationship. Find the percentage decrease in price when big piece of a diamond breaks into three parts where the weights are in ratio 1:2:2. So we have a big diamond now. It's going to have some price. Now it gets broken into three pieces with individual weights 1x, 2x and 3x. So let's assume that the weight of original diamond was 5W. This will add up to 5, right? So let's go, original diamond is going to be 5W in weight and original price is K times 5W square, correct? So original price is going to be 25 kW square. Now this gets broken into three pieces. Let's say piece 1, piece 2 and piece 3. Piece 1 has weight of W, piece 2 has weight of 2W, piece 3 has weight of 2W. This is given 1:2:2, right? And they should add up to 5, correct? So price 1 is going to be K times W square using this equation. Price 2 is going to be K times 2W square, which is going to be 4KW square, and price 3 is also going to be, it has the same weight, so it is going to have this the same price also, 4KW square. Okay. So now original price was 25 kW square and individually these prices are kW square, 4KW square and 4KW square. So total, if you sell all the three diamonds, we are going to get 4 plus 4 plus 1, 9 kW square. So this is the total price. So just because the diamond got broken, I got a huge decrease in the price. From 25 kW square, I came down to 9 kW square. So what is that percentage increase? What is that percentage decrease? That is the question. Right, so the percentage decrease is going to be original value minus new value divided by original value into 100. So that's going to be 16 kW square and kW square will get cancelled. 16 by 25 into 100. So we are talking about 64% decrease. So let's now move to this problem. Please pause the video and see if you can solve this. The salary of Jack includes a fixed component and a variable component. The variable component involves $100 for every additional car that he sells after the first 20 cars. If Jack sold 30 cars and drew $4,000 in May, what is going to be his salary in June when he draws, or rather he sells 45 cars? Okay, so let's say salary is going to be fixed component plus $100 for every additional car. So if he sells total of X cars on top of 20. X is on top of 20. He is going to make every $100, $100 for every car plus a fixed component. So this is basically the equation. The fact is, if Jack sold 30 cars, that is what is going to be X on top of 20. How many extra cars he sold? He sold 10 cars. Sold 10 cars plus F. His salary was 4,000. Right? So what we can say? We can say that F is going to be 4,000 minus this is 1,000. So F is going to be 3,000. So he gets paid $3,000, and on top of that, for every car he sells over 20 cars, he is making $100 extra. So what is his salary in June when he has sold 45 cars? So in 45 cars, X is going to be 45 minus 20 is equal to 25. So this 25 cars into 100 for every car plus the fixed component is going to be his salary. So that is going to be 3,000 plus 2,500, 2,500. So that's going to be $5,500. So in June his salary is going to be $5,500. Let's move to the fourth problem. Please give it a try. The speed of a cart decreases by X miles per hour with every additional box loaded on it. Okay. With 10 boxes, the speed of the car was 25 miles per hour. With 30 boxes, the speed was 15 miles per hour. Okay, so we know this equation speed is, and we have to figure out what was the speed of the cart with no box loaded on it. Let's say this speed is original speed. Right, so the new speed is original speed minus X miles per hour for every one box. So if it number of boxes is 1, it's going to be original speed minus X miles per hour. If number of boxes is 2, it is going to be original speed minus 2 times X, that way. So this is the basic equation we got. Let's put the facts in this. With 10 boxes, this is going to be minus 10x. With 10 boxes, we don't know this, so S original minus 10x, the speed is going to be 25 miles, and with 30 boxes, it is going to be S original minus 30 boxes. His speed is 15 miles per hour. So we have two equations, two variables, pretty straightforward. Let's equate S original from both. So S original from one equation is 25 plus 10x, from other equation it is 15 plus 30x. So let's now only focus on this part. So what we get is 10 is equal to 20x, so x is equal to 0.5. So whenever you load an additional box, your speed decreases by 0.5 miles per hour, right? And what is going to be S original? S original, you can put x is equal to 0.5 in any of this equation. Let's put x equal to 0.5 here. So what we get is S original is equal to 25 plus 10x, which is going to be 5. So it is 30 miles per hour. Right? So let's verify if this solution is correct. So S original is 30 miles per hour. I load 10 boxes. So with every box, the speed slows down by 0.5. So for 10 boxes, it is going to slow down by 0.5 into 10, which is 5 miles. So now I am going to get 25 miles per hour speed, which is correct. Also with 30 boxes, my speed is going to slow down with 30 into 0.5, which is 15. So 30 original speed minus reduction of 15 miles, I am going to get 15 miles per hour, which is also correct. So this means our solution is correct. The solution is original speed is 30 miles per hour. Let's move to problem 5. See if you can solve this. 40% alcohol solution is mixed with 50% alcohol solution. Now whenever you have this solution, 40% concentrated solution, what it means is for 100 ml of the solution, 40% of that is alcohol. That means 40 ml is alcohol. Now this is the first type of solution. Second type of solution, for every 100 ml, 50 ml is alcohol. That way. What percentage, what is the alcohol percentage in the resultant solution if the solutions are mixed in ratio 1:3? Let's say I mix 1:3, right? So for sake of simplicity, I'm going to say 100 ml of this and 300 ml of this solution, right? Giving me total of 400 ml. 100 ml of solution, here we have 40% concentration, so we are going to have 40 ml of alcohol. This is the entire solution, this is alcohol. Here we have 50% alcohol, that means out of 300 ml I'm going to have 150 ml as alcohol, so total alcohol is going to be 190 ml, right? So what is the concentration of alcohol in this new solution? The solution is 400 ml, out of which alcohol is 190 ml, so the concentration obviously is going to be 190 divided by 400 into 100, this much percentage. That is going to be 190 divided by 4, which is 47.5%. So the new solution is going to be 47.5% concentration of alcohol. Let's move to this problem. Please pause the video and give it a try. The ratio of marbles Julie had to marbles Gabe had was 4:9. So let's say Julie has J marbles, Gabe has G marbles. So it is Julie to Gabe is 4:9. Okay. After giving some marbles to Julie, now obviously Gabe has more marbles because he has 9 marbles for every 4 marbles Julie has. So he gives some marbles to Julie. So let's say he gives X marbles to Julie. So now how many marbles he has? He has these many marbles. Julie has these many marbles, right? See, X, this is going to be G minus X, this is going to be J plus X. Now Gabe has 6/7 as many marbles as Julie. So this is 6/7 as many marbles as Julie. Okay. Now you will see that there are 3 variables here, J, G and X. We don't really, with 2 equations we can't actually solve for 3 variables, right? But we have some additional piece of information. What we have is how many marbles did Gabe give Julie. That means it is asking for, the question is asking for X. If Gabe originally had 45 more marbles than Julie, so there is this piece of information that will help us further. So Gabe originally had 45 more marbles. Julie has 4K marbles and Gabe has 9K marbles. Okay, and how many more marbles does Gabe have now? He has 5K more marbles, right? Julie has 4K, Gabe has 9K, so Gabe has 5K more marbles, and that is equal to 45. This is given. So that means K is going to be equal to 9. That means Gabe is going to be 9K, which is 81, and Julie is going to be 4K, which is 36. So now we solved for G and J. Let's put those values here now. G is 81, so we get 81 minus X is equal to 6/7, 46 plus X. Correct? So let's do that now. What we get is 7 times 81 minus 7X is equal to 6 times 36 plus 6 times X. Right, so 7 times 81 is going to be 567, sorry, minus 6 times 36 is going to be 216 is equal to, this 7x goes here, so it becomes 6x plus 7x, 13x. So this is 13x is equal to, this is going to be 351. So x is going to be 351 by 13, so it's going to be 27. So that means Julie gets for 27 marbles from Gabe. Now in this kind of equation, it is always a good idea to put these numbers back and see if they make sense. So originally Gabe had 81 marbles, Julie had 36 marbles. So Gabe gave 27 marbles to Julie. So that means now he has 81 minus 27 marbles. So he has 54 marbles. And now Julie has 36 plus 27 marbles. So that is going to be 63 marbles. Now, are they in a ratio 6:7? Yes, they are in a ratio 6:7. So 54 by 63, if you divide them by 9, you get 6 by 7. So that means all these numbers fit in, and this is the correct solution. The answer is Gabe gave 27 marbles to Jude. Let's move to this problem. Please pause the video and give it a try. 30%, 40% and 60% alcohol solutions. So there are three solutions, 30%, 40%, 60%, are mixed in the ratio 2:3:5. What is the percentage of alcohol in the resultant solution? Pretty straightforward. They are mixed in ratio 2:3:5. Let's say I'm taking 200 ml of the first one, 300 ml of the second one, 500 ml of the third one. What is going to be the total solution? How big is that going to be? It's going to be 1000 ml, right? Out of this, what is alcohol? First one has 30% alcohol, so that means it's going to have 60 ml of alcohol. Second one has 40%, so it's going to be 120 ml. Third one has 60% alcohol, so that's going to be 300 ml. So total alcohol is going to be 60 plus 120 plus 300 is going to be 480 ml. Right? What is the resultant percentage of alcohol in resultant solution? It's going to be 480 ml divided by 1000 ml, so it's going to be 48%. So the resultant solution is going to have 48% alcohol. So with that, I thank you for watching the video. I hope you learned a good deal about ratios, proportions and variations, and I look forward to seeing you in the next class. Thank you.